Your AI agent can research a highly technical topic, synthesize messy data into a clean report, and autonomously refactor your codebase. It has mastered complex intellectual execution. This diagram shows a split-screen logic flow that highlights a fatal operational flaw. On the left, we see an endless looping cycle of code generation and data analysis. But on the right, the moment that same agent needs to acquire an external resource, the logic pathway hits a hard stop at a 402 payment required barrier. The agent cannot autonomously pay for the tools it needs to finish the job. At Own Your Mind, we operate as an independent, sponsor-free research platform. We analyze the actual data beneath decentralized AI networks to see what is working in production. Right now, the plumbing that allows AI agents to hold wallets, spend money, and pay each other is actively shipping. But there is a stark divergence between the payment infrastructure that exists today and the actual economic volume flowing through it. We need to audit the self-reported agent payment metrics, map the cryptographic execution stack that allows this to work safely, and isolate the specific protocols positioned to survive the next development cycle. This architectural blueprint of an unfinished skyscraper models the current state of decentralized AI. The foundational concrete is poured. The structural steel frame is securely bolted in place. The building can support weight, but right now, there are 0 tenants inside. The only way to accurately predict when this autonomous agent economy will actually begin is to strip away the marketing narratives and look strictly at verified on-chain realities. The most concrete implementation of agent commerce is X402, an open protocol built by Coinbase that takes the long-dormant HTTP 402 payment required status code and repurposes it for machine-to-machine interactions. When an agent requests an API resource, the server replies with a price. The agent pays using stablecoins, the transaction settles on-chain via a payment header, and the agent receives the data. It bypasses user accounts, API keys, and KYC checks entirely. This funnel breaks down the headline vanity metric of March 2026, a reported $24 million in payment volume, but independent on-chain analysis dropped that volume to roughly $3 million. Finally, a wash trade filter removed endlessly recycling funds, shrinking the total again. The rigorously verified final bedrock metric for agent economic volume was $1.6 million. 3 distinct factors explain this tenfold gap. First, the original $24 million figure was entirely self-reported from Coinbase's own facilitator logs, without any independent third-party audit to back it up. Second, Coinbase heavily subsidizes the gas fees for X402 transactions. By covering the network costs, they remove the standard economic friction that naturally prevents high-volume testing and spam. Third, X402 uses a specific settlement mechanism known as EIP 3009. On a block explorer, these transactions look completely identical to normal human users transferring USDC to each other. Because the settlement layer is indistinguishable from human activity, third-party verification of purely agent-driven volume becomes highly complex. Even at that drastically reduced volume, that $1.6 million is actively powering legitimate pay-per-request microtransactions. Developers are using it to buy individual web scraping queries, and enterprise sales teams are pointing AI agents at X402 endpoints to autonomously source leads for pennies a request. $1.6 million is an objectively small number for global infrastructure, but it provides the first empirically verifiable proof that the pay-per-request agent-to-service economy is technically functional. Knowing how agents pay is only half the equation. We have to look at how they physically execute these transactions, because granting an AI raw, unconstrained on-chain capability introduces a critical security vulnerability. The primary execution framework making this possible is Coinbase AgentKit. It provides an agent with over 50 specific on-chain actions out of the box, allowing it to transfer tokens, swap on decentralized exchanges, and deploy smart contracts. But broad capability requires equally strict limitations. This is why infrastructure providers like Privy have adopted a security-first, constraint-based wallet architecture. In live production environments, developers reject unbounded autonomy. Instead, they attach strict spending limits, specific allowed chains, and rigid transaction rules at the exact moment the wallet is created. This diagram maps the danger, exposing private keys directly to an AI's prompts or memory. If the agent reads them, they can be stolen. The solution isolates that data. Keys are only reconstituted within secure enclaves during the exact moment a transaction is signed. The operational outcome of this separation is absolute security against malicious prompts. An agent that suffers a prompt injection attack from an outside user cannot exfiltrate its own funds. The agent cannot steal the capital because it never possesses the raw cryptographic keys within its accessible state. For institutional-grade decentralized AI, autonomy is not a default unbounded state. It is a highly specific privilege enforced by rigid cryptographic guardrails. Building safe wallets is necessary, but the industry still struggles with a foundational misconception regarding what goes inside them: the assumption that AI agents should transact using project-specific volatile utility tokens. This line chart demonstrates why volatile crypto tokens are a catastrophic medium of exchange for automated entities. If an agent operates on outcome-based pricing, its fixed API compute costs clash constantly with the spiking and crashing value of the native token it earns. An agent cannot reliably budget for compute resources or price its own services if its revenue currency drops 30% in a single day. This is exactly why functional agent payment layers bypass native tokens entirely. They intentionally rely on stablecoins, like USDC, to guarantee predictable settlement. We can see the consequences of ignoring this economic reality by looking at the Olas paradox. On the surface, the Olas network boasts impressive metrics. They have thousands of deployed agents, executing tens of millions of agent-to-agent transactions on-chain. But when you look at the actual economic throughput on their MEC marketplace, where agents pay other agents for services, the total turnover is only in the tens of thousands of dollars, not monthly, total. This paradox proves a vital point about the current market. Agents are successfully communicating and executing transaction logic, but meaningful economic value is not yet entering the loop. This three-tiered pyramid models how these infrastructure constraints dictate the macro application layer, dividing the timeline into three specific iterations of decentralized AI. Iteration 1, abstraction layers, allowed users to give agents natural language commands to generate yield. This failed. Natural language is too imprecise for financial operations. Iteration 2 solved this with autonomous agents, set and forget algorithms managing positions strictly within defined DeFi guardrails. This is the current working tier. Protocols like Giza successfully manage tens of millions in assets by enforcing explicit strategy boundaries. Next comes Iteration 3, AI vaults. This incoming phase uses swarms of specialized agents to autonomously write, test, and deploy DeFi smart contracts. This structure solves the institutional trust problem. Large capital allocators refuse to deposit funds into a black box AI model, but they will deploy capital into transparent, fully auditable smart contracts, even if an AI wrote the code. The protocols succeeding right now share a clear pattern. They are abandoning unbounded token speculation and moving entirely towards stablecoins and rigidly defined execution loops. Returning to our Skyscraper blueprint, we see the state of the market. Marketing narratives claim the agent economy has arrived, but on-chain data proves we've only built the framework. The foundations, AgentKit, Privy, X402, and stablecoins, are illuminated and functional, but the floors above remain dark. The primary macro component missing from the structure is true agent-to-agent service markets operating at a meaningful, sustainable scale. These markets are currently blocked by a trust barrier. Agents lack a standardized identity infrastructure. Without it, an agent cannot trust or verify an unknown, autonomous counterparty on-chain to purchase compute or data. The most thorough attempt to clear this barrier is ERC 8004. It proposes lightweight registries for identity and reputation scores, but it remains a draft standard with no production deployment. The developer teams poised to win the next cycle share strict characteristics. They are not chasing consumer engagement metrics. Instead, they are entirely focused on solving the boring, vital infrastructure problems: robust key management, on-chain policy enforcement, and identity verification. They are building the plumbing, not the penthouse. Once that identity layer is solved, the macroeconomic impact will be significant. Autonomous entities will function as a systemic demand-side multiplier for the decentralized compute and inference networks already operating today. The timeline for a fully occupied agent economy is longer than current hype suggests, but the structural foundations to support it are now in place. To read the full, unfiltered analysis of the decentralized AI infrastructure stack and see exactly which protocols are shipping real code, visit ownyourmind.ai.